Welcome to day 9 of our 101 Days of Data Science. Today we're diving into statistical distributions. Distributions describe how data is spread out and help us understand patterns and make predictions. We'll cover 3 common types: the normal distribution, the binomial distribution, and the Poisson distribution. Let's break each one down and see how they work with some Python examples. The normal distribution, often called the Gaussian distribution, is a symmetrical bell-shaped curve. It's one of the most common distributions you'll encounter. Many natural phenomena follow this pattern, such as heights of people or measurement errors. Let's see one example where we generate data following a normal distribution, and the outcome is a visual representation of this distribution. In this example, we generate 1,000 random data points using the NumPy library, where the data follows a normal distribution with a mean of 0 and a standard deviation of 1. The histogram we plot visually represents how the values are distributed. The outcome is a bell-shaped curve, which is characteristic of the normal distribution. Most data points cluster around the mean, 0, and as you move further away from the mean, the frequency of values decreases, resulting in a smooth, symmetric curve. The binomial distribution models the number of successes in a fixed number of trials, each with the same probability of success. For example, it can model the number of heads when flipping a coin multiple times. Let's assume we want to find the distribution of the number of heads if we flip a coin 10 times, and we want to check the result in 1,000 experiments. The histogram visually represents the distribution of the number of heads in 10 coin flips. Most outcomes cluster around the middle, 5 heads, with fewer instances of getting very few or very many heads. The Poisson distribution models the number of events occurring within a fixed interval of time or space, given a constant average rate. It's often used for rare events like the number of meteorites hitting the surface of the Earth in a year. This time, we want to find the distribution of the number of meteorite impacts on Earth in a year and check the results over 1,000 simulated years. The histogram visually represents how frequently different numbers of meteorite impacts occur based on an average rate. The histogram provides a visual representation of how meteorite impacts are distributed annually, highlighting that while the average number of impacts is around 5, the actual number of impacts in any given year can vary, with fewer extreme values occurring less frequently. Statistical distributions describe how data values are spread and help us understand and predict patterns, with key types including normal, binomial, and Poisson distributions. Next time, we'll compare Bayesian and frequentist statistics, examining how Bayesian methods incorporate prior beliefs and frequentist methods focus purely on data for statistical inference.